Okay, for those of you taking the M step, here is 10.4. 10.4 talks about comparing linear, quadratic, and exponential models. We're going to give a data set. We're going to look at the graph, the table, try to write an equation, try to figure out what kind of model it's representing. So if we remember, there's certain things we need to remember for a linear, quadratic, and exponential. Hopefully you remember this stuff. A linear is always going to be a straight line. Quadratic we know is always going to be a U. And we just learned about an exponential. An exponential is always going to be some sort of curve that gets really, really close and shoots up. So there's our graph. The equation for linear we know has no funny stuff. Y equals mx plus b. There's no crazy exponents. We know quadratic always has an x squared. And an exponential always has something to the x power. So like 2 times 3 to the x power. Can't write for some reason. There you go. And then if we look at the table, do you remember what makes a linear table linear? It's that the first difference is constant. That means we add or subtract the same thing every single time. Quadratic, it's the second difference. So remember, you do it twice. You do it first time and then you do it again. And the second difference, you have to be adding or subtracting the same amount every time. And then we just learned about exponential. Exponential would mean that we'd multiply by the same thing every time. So that's kind of a general summary. So what I'm going to do on the test is I'm going to give you some tables of data. You have to look at them, figure out what kind of graph they are. Is it linear, is it quadratic, is it exponential, and then in some cases write the formula for those. So we know, like when we did the M&M experiment, that real life isn't always perfect. Sometimes it doesn't make the perfect smooth, perfectly clean curve, but it should come very close to one of these. So if we have some data and I am not sure what to do with it, we can graph it. That's always an easy way and see what kind of picture it makes. And again, it might not be perfect. You might be missing some information. You might not be able to tell exactly what it is, but it should be generally a U. Or, you know, this is a little bit off right there, but generally this is pretty much a straight line. And this we can tell is pretty much a swoosh. So graph the data. It should come pretty close to being one of these three. And real life's not perfect, so we don't expect it to be clean and smooth and all of that. So this right here just says plot the data and see what you see, and you can do that. You can also pick up on some clues when you look. We know that quadratics split in half. So I've got the middle here and it splits, splits, and it splits. So I know this is going to be a U, so I can kind of tell without even graphing this one. But if you wanted to plot the data, you could. This one, we can kind of tell it's going to be exponential because it grows really, 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 really fast. So I have to be multiplying by something. And this one here you have to be careful of because it doesn't, your x values don't go up by the same amount. So this one you'd probably want to put on a graph and see what's happening. And it should be a line or a curve or a U. The other way we can do this is we can look at the table. So remember, linear, we said the first difference has to be constant. Quadratic, the second difference, and then for exponential we multiply. So we're going to check those things. So I'm going to look at this right here. I'll first check the first difference. That's going to be plus 64. This is going to be plus 32. This is going to be plus 0. This is going to be minus 32. So it's definitely not linear. Check the second difference. This is going to be minus 32, minus 32, minus 32. Second difference is constant, so this is a quadratic. Right here I can check the first difference. This is going to be plus about $170, roughly, 169.86. I don't know what that is, so we'll have to crunch that. But I can tell this one right here is plus like 300, so that looks pretty big. So I'm already suspicious, but let me crunch these numbers and I'll turn this back on. Okay, so I filled those numbers in for you there so we can see that this is not linear. And then I can look at this and I can also see it's not going to be quadratic because from 170 to about 200, that's about 30 or so. and then this is a little bit more than that. You can crunch those numbers, but those are not the same. So if it's not the first difference, it's not the second difference, I'm going to check exponential. So exponential has to be multiplying. So if I take the second one and I divide by the first one, I'm going to get 1.169. If I take this one and I divide by that one, I'm going to get 1.169. If I take that and divide, I'm going to get 1.169. So this is an exponential function because I'm timesing by 1.169 every time. So this basically says after we figure out what the model is, we can write the equation for it. So if you remember your three equations, we've got linear is y equals mx plus b. We've known that all along. We got our quadratic and our exponential. I'm going to make you write these two on your test because we've done them for so long. You've got your starting amount and you've got your changing amount, your slope. Same thing here, you've got your starting amount and your changing amount. This one gets a little bit more complicated, so I will not have you write those on your test. So let's do a couple examples. So this one here, it says first figure out what kind of data it is, and after you figure it out, we're going to write the equation. So you can kind of tell by looking that it goes up really fast. So if you had to guess, hopefully you'd guess that it's exponential. And if you're not sure, then you're going to check. 56 divided by 8 would be times 7. 392 divided by 56 would be times 7. And 2744 divided by 392 would be times 7. So now you're going to write the equation for this. So we know an exponential equation is y equals a times b to the x. We know that a is always my starting amount. So what is your starting amount in this story? Your starting amount is right here at 0. So your starting amount is y equals 8. What is your changing amount? B is always your changing amount, and here is your changing amount. We are timesing by 7 every time, and then it's going to just be to the x because we can plug in anything that we want. Then this says use your function to predict the number of people who receive the email after 1 week. Well, how many days are in a week? There are 7 days in a week. So now if I want to plug 7 into this, I can do 8 times 7 to the 7th, and I can answer that question. Okay, next one, I think this is the last one. Look at the table. It doesn't take too long to figure out that we're going minus 50. I don't know why that won't write. Minus 50, minus 50. Okay, so this is definitely linear. So when I want to do a linear equation, I've got y equals mx plus b. We know that b is always our starting amount. So what is our starting amount in this equation, or in this graph? It's right here at 0. So my starting amount is going to be plus 375. And then we got to find our changing amount. Be careful with your changing amount. Your changing amount's not just negative 50. Your changing amount is rise over run. So always make sure you do y over x. Make sure you don't flip it over. But we're going down 50 over 10, down 50 over 10, down 50 over 10. So down 50 over 10 is going to give me a slope of negative 5x plus 375. And then it says use your function to predict the temperature after 1 hour. Well, this is minutes, so we've got 30 minutes. So if we plug in 60, 60 times 5 would be 300. So negative 300 plus 375 is going to equal 75. So hopefully that does it, and I'll see you back in class tomorrow.